Hello everybody, today we're doing evaluate reverse Polish notation. What this means is that a reverse Polish notation is basically using a stack. So this is like stack type problem. So in this problem we have a token and this is our input, output. And what we see here is that we have 2, 1, and then we have additional sign, and then we have a 3, and then multiplication sign. What happens is that once we see a with Polish reverse Polish notation, we take the 2 plus the 1, and we see operator that happens first. And so basically that creates this situation where we have 3 times 3, which is equal to 9, and that's why we have our solution as 9. And this means that we should use a stack to process this. By putting the numbers in and having, when we see operating those items in the stack. The question here is, would there be possible outputs that are bad? What I mean by that is that, like, would there be a case where there would be like division by 0 errors, or would there be like impossible to evaluate because there are no operators, there are only operands, or there are only operators but no operands. By operators, I mean the multiplication, addition, subtraction, and division. If they're only operators, then we can't operate on anything. But it looks like what they're saying here is that it'll always be good, like 100%. Like all solutions are good. So if that's the case, then there are no edge cases that we have to handle for. That means that we can just get straight into coding. But the time and space complexity that I'm predicting here is going to be O of n to go through all the items, and the space of O of n to store everything in our stack. So go through all items, go store all items. So the reason why you would have something that would store all items is that you have a bunch of numbers, right? And then you have a bunch of addition signs all after it. So you have to store all of these numbers here, n numbers, and you have to basically n divided by 2, but you still have to get all the addition signs into it. You have to have like 8 operands, and you have to have 7 operators. Okay. So with that, we are good I think we're good for the understanding, and we are able to move on to the next step, which is matching. And I think we did a little bit of that already. We're going to be doing a stack. So the reason why we chose a stack was because of the reverse Polish notation, and that operates. We have to use a stack to process this type of problem. So, okay, here's the plan. We create a set of operators, and for each token, we store if not operator, if operator, we compute and store results in stack. How does reverse Polish notation works is that it takes the A plus the B and then does the operation A plus B. So B will always be the first one that's popped off, and the second one will always be the first item. So 1 and 2, A1, A2. Okay. With that, then we'll return the last item. Okay, let's implement. So let's create some operator. A set of items. Let's say plus minus divide times divide. All right, great. I think That should be all for our operator. That's our first step. Then we're going to move through all the items one time. So we need a stack to store items, and for token in tokens, if token equals in operators, then what happens is that we will then do an operation. So operam equals stack.pop, and if token equals plus, then we just need to do addition then. So stack at -1 is equal to the top of the stack plus the operand. And we do the same for the rest of these operators. So it's very straightforward. I'm just typing it out right now. There's nothing much to say. Stank is not the right word. Otherwise, we're gonna put the item into our stack. So stack.append. What we're gonna append is our token. What we need to do is make an int. And with that, once we're all done with everything, we should have one item left in our stack, which is our last item, which is 0. So that's it. That's everything. We should do a review. Let's review it and see what happens, and make sure that we are getting the right input and output. So let's check it out. So we have a stack. We put 2 in. Then we put the 1 in. Then we do an operation called a plus. We see a plus. That means it's an operator. So we pop the first one. So operand is equal to 1. And 2 is another operand. And we do addition to them. So we get a total of 3 into our stack. With that, we are ready to get the next item, which is 3. So we just put that straight into our stack. We have 3. And we have multiplication sign. So that means this operand is now 3. And 3 times the next item, 3, which is 9. And that's it. And we got the right answer. Let's run it and go from there. Aha. So what happened here was a typo. And everything looks good. Let's do an evaluation as we submit this code. Evaluation is again O of n. Oh, look at that. We have an issue. We have a 6.6 over we should have done a floor division, it looks like. And that was the issue. Let's take a look if that's the case. Interestingly enough, I didn't know that was supposed to cause a floor division, and now we have another error. Okay, I'm gonna give myself a little pause to make sure what's going on and why it's causing this issue. Alright, back again, and the error was a different type of flooring. it was supposed to be like not a floor. It's supposed to be an int, so the closest item, and that's supposedly the right answer. I don't know where it says that, uh, like about the division, but oh, there it is. The note: the division between two integers should truncate towards 0. So it's not. It doesn't floor, nor does it ceiling. So it's just whatever it's closer to, and we'll go towards that 0. Yeah, I did not read that, and that's why it caused a little confusion there. But the evaluation is going to be O of n, because we go through all the tokens. And the space is O of n because of stack. And that's it. If you enjoyed this video, like and subscribe. If you want more videos, check the link in the description below. Thank you very much, and I'll see you in the next one.